Hey guys, Mr. B here. In this video, we're going to be going over the chapter 18.1 notes on what causes climate. So we're going to be talking about climate versus weather, what factors influence temperature, what factors influence precipitation, and lastly, talk a little bit about the seasons. All right, so as you know, weather and climate are similar but different. Okay, weather, of course, is typically going to change on a day-to-day basis, even an hourly basis. At one location, it might be cloudy and rainy one day, and then it might be clear and sunny the next. That's typical weather. Climate, on the other hand, typically refers to the average year after year conditions in that location, and it's not just the weather patterns itself, but it's temperature, precipitation levels, winds, clouds, all that stuff. And it takes a very long time to change. Okay, weather changes much quicker. Climate takes a very long time to change because it's an average. So there are some locations certainly that have their own climate conditions that are different from those around them, and they're considered to have a microclimate. So, for example, here in Minnesota, we have locations like Duluth, Minnesota, which are right on Lake Superior, that have a much different climate than the rest of the state because they're right next to a very large body of water. And later on then in this section, we're going to talk about how big bodies of water affect climates. But Duluth has a much different climate than we have here in Watertown, Minnesota. So Duluth would considered to have a microclimate. Okay, so Duluth would be considered to have a microclimate, mainly because of how Lake Superior affects it. So what factors influence temperature when it comes to climate? So there's four main factors that we're going to be talking about. There's latitude, altitude, distance from large bodies of water, and ocean currents. Okay, latitude is going to be where you are in location to the equator, whether you are on the equator or further away near the poles. Altitude is how high up in the air you are. So if you live at the top of a mountain, or if you're way down below sea level in a valley, that will have an effect. Distance from large bodies of water could be again near the ocean or large lakes like Lake Superior, and ocean currents as well. So latitude in general, climates of locations that are near the equator are usually going to be a lot warmer than locations that are farther away. And this primarily has to do with how the sun's rays hit the surface of the earth. So at the equator, the sun's rays hit the earth at a pretty 90-degree angle, or pretty square on. Okay. And as you move away from the equator, because the earth, of course, is a sphere, the sun's rays are going to hit more at an angle, and a lot of that light is going to reflect off into space instead of getting absorbed by the ground, which ultimately is going to result in a cooler temperature in that location. Okay? So the sun's rays have a big effect, of course, on the climate and the temperature on Earth and where you are and located to the equator. Typically, the Earth is broken up into three different temperature zones. We have the tropical zone, which is basically on the equator and about 23.5 degrees north or south in either direction. So if you think of rainforests and, palm beaches and all that stuff, that's typically going to be a location that's somewhere in this tropical zone, right? Whether it be in Mexico or South America, or way kind of down in the Caribbean or Africa, places like that. As you move up away from that tropical zone into the 23.5 to 66.5 degrees, so this is kind of in between the top and bottom of the planet where we live, this is the temperate zone. So these are the zones where you actually have seasons, right? It's not sunny and warm all the time, all year round. It's also not cold and winter and snow all the time, all year round. You get both, right? So we have our summertime like now, where it's nice and warm and it's sunny and sometimes too warm and humid. And then, of course, we have our winters where it gets brutally cold and it snows and stuff like that, right? And then, of course, at the very top and bottom of the planet, you have the polar zones. This is, of course, where it's frozen, typically winter all year round, right? So this, again, has to do with where you are in relation to the equator and how the sun's rays are hitting the surface of the planet at that location. So tropical zone, again, we'll just recap real quick. Tropical zone is right on the equator, or 23.5 degrees up or above. Basically, sun shines all year round. Climate's very warm, sunny all the time. Polar zones are on the top and the bottom of the planet, where the sun's rays are always striking at a very low angle. And so we have the north and south poles, very cold climates, frozen winter all the time. And then the temperate zones, which is kind of in between those, where we have both warm and hot summers and cold and cool winters, because again of how the sun's rays strike the surface of the planet at those locations. All right, next up we have altitude. So altitude also plays a big role in your climate. In the case of very high mountains, altitude is a more important climate factor than latitude. For example, Mount Kilimanjaro, which is a mountain found right in Africa, basically right on the equator, has a very cold climate because Mount Kilimanjaro is very, very high up in the air. So if you're way down at the base of the mountain, it's probably very warm and sunny and pretty tropical. However, at the very top of the mountain, it's always covered in snow. All the time, all year round, always cold because of how high up in the air it is. Okay, so as you move higher up into the atmosphere, the temperature decreases by about 6.5 degrees Celsius for every 1 kilometer that you go up. So basically, very, very high locations have very cold temperatures all year round. Okay, all the time. So low locations then typically have warmer climates, and this altitude change will have a bigger impact than the latitude. So it doesn't matter if you're on the equator or near the poles. If you're high up in the air or low down in the ground, that's going to have a bigger impact than just simply where on planet Earth you are. Large bodies of water also have a big impact. So oceans or large lakes can affect temperatures. Oceans are going to affect them a lot more than lakes will because they're bigger bodies of water. But either way, both of them do this. So the reason why is water takes a very long time to heat up. It takes a very long time to cool down. Whereas land heats up and cools down a lot faster. So if you're near an ocean or a body of water, that body of water is going to act sort of like a heat sink or a heater. So it's going to absorb a lot of the heat in the summertime, which is going to essentially cool down your summers so that your temperatures are not so hot. And in the wintertime, because that body of water is holding the heat, it's going to release that heat into the air in the wintertime, so your winters aren't going to be nearly as cold either. So places that are near large bodies of water tend to have more mild summers and more mild winters. Their summers aren't crazy hot, humid like ours are here in Minnesota where we're landlocked, and their winters aren't also brutally cold and stuff like ours are because we're landlocked. So a good place to think about for this one would be like Seattle, Washington. Typically, their summers are pretty cool all the time, and their winters also pretty mild. They don't really have crazy extremes in either direction. It's it certainly gets warmer in the summer. It certainly gets a little bit cooler in the winter, but not like here. Okay, so we call these places the climates in these locations marine climates because their mild winters and cool summers are different from those that are in locations that are more continental. Okay, so the centers of North America and Asia, which are much too far inland to be warmed by any ocean or cool, again, like here in Minnesota, we're landlocked, and most in Canada and Russia have continental climates, where we have more extreme temperatures than marine climates. Our winters are very, very cold. Our summers can get very, very hot. And we kind of get those both extremes, right? And again, talking about Duluth, Minnesota, where it's on Lake Superior, their winters and their summers aren't quite as cold or quite as hot as ours are. Now, granted, they certainly still get cold and they certainly still get hot. I went to college in Duluth, so I understand exactly how cold it can get and stuff like that. But typically, on average, their temperatures aren't quite as cold as ours are here in Watertown, and they're not quite as hot as ours are here in Watertown either, because Lake Superior does absorb a lot of the heat that is given off by the sun, and it holds that heat in the wintertime, and it gives that heat off, or it holds that heat and gives it off in the winter, or it stores it in the summer. So, all right, and the last thing we have here are ocean currents. So marine climates and other places that are on the ocean, not only are they affected by the ocean absorbing a lot of heat and stuff like that, but the oceans themselves move. Okay, there's currents that move all of the water in the oceans around the whole planet. So the ocean will absorb a lot of the heat from the air, and then these currents will circulate it around the globe. And so this warm water, maybe from the tropics, will move upwards towards the poles, or cold water will move inwards. And so we get the ocean itself, which is transferring and transporting heat around the globe. And then that heat can get released into the air, which will then warm up the temperature in certain locations or cool it down. So places that are on the ocean, again, are affected not only from the ocean itself absorbing heat and stuff like that, but the ocean currents that are moving around will also affect the climate there, which will cause it to maybe be a bit warmer than it should be or a little bit cooler than it should be, as, again, the warm air and the warm ocean water releases that heat into the air, which then moves over the land and then cools it down or heats it up. So this little map here kind of shows a lot of these ocean currents. Again, a lot of these warm currents are moving upwards, especially in through like the Caribbean, things like that. One very important one is the Gulf Stream, which moves from the Gulf of Mexico across the Atlantic into and around England. So England actually, which is higher latitude-wise than here in Minnesota, typically has much milder winters and milder summers than we do here in Minnesota because of the fact that they have this warm ocean current that's moving from the tropics up to them. And so they have a little bit more of a tropical climate a little bit there. So these ocean currents have a big impact on how climates are affected. Okay, so all right, some questions here. Again, we're gonna skip past these. If you want to watch me go into those, I have a video on that. We're just gonna keep on talking about some information. So other than temperature, precipitation also is a factor in climate. So what factors influence this? We have three main ones. Okay, we have prevailing winds, presence of mountains, and seasonal winds. We'll talk about each one of these in particular and how they impact the rainfall. So prevailing winds. So weather patterns depend on a huge movement of air masses. Okay, weather typically has to do with high pressure and low pressure systems. And so how the air moves from one place to another is what we call prevailing winds. And the directional winds that are usually blowing in a region are indicated by these air masses. So air masses can be warm or they can be cool. They can be dry, they can be humid. The amount of water vapor in the air is going to determine how much rain or snowfall that location will get. So winds that are typically blowing in from an ocean or a large body of water are going to carry a lot more water vapor, and they're going to carry that onto the land. And so those locations are typically going to get a lot of rainfall or snowfall pretty often. Again, if we think about Seattle, Washington gets a lot of rainfall. In fact, it's one of the most rainiest locations in the United States. That's because, again, it's right on the ocean, and air from the ocean gets blown inwards. It carries a lot of water vapor and then gets dropped onto the land. So they get rain all the time. Duluth, Minnesota gets very, very heavy snowfalls, okay, a lot of times of the year. Because, again, a lot of the water vapor from Lake Superior gets blown onto the land and then it drops out of the air and it then falls down as snow, right? Or places on the East Coast like New York and Boston. A lot of times, like every year, we hear about these giant snowfalls that they get. You see these pictures of, people that have like 3 feet of snow on top of their cars. They're trying to shovel it off because they're right on the ocean and how the currents are blowing and the winds are blowing. So the direction of wind patterns in different locations will have a big impact on the amount of rainfall they get, especially if they're near a large body of water, because a lot of that will get pulled onto the land. So mountain ranges also play a big impact, especially when it comes to prevailing winds. So humid air, again, will blow from the ocean towards the land. Okay, so a lot of water in the air go onto land. That air is forced to rise as it goes up the mountain range. So if there's a mountain range there, that air is going to get pushed upwards as it tries to get over the mountain, right? As it goes up in the atmosphere, temperature is going to drop. And as the temperature drops, that water vapor, which was a gas, now is going to condense to a liquid or potentially freeze as a solid. And as it does so, it gets heavy and it's going to fall out of the air, okay? And so when it falls out of the air, of course, it's going to be either rainfall or snowfall. And so places that are on the windward side of the mountain, so places that are on the side that the wind is blowing up the mountain, are going to get lots of rainfall or lots of snowfall. However, on the other side of the mountain, okay, the leeward side, typically it's going to be very dry there because most of the water vapor and humidity is going to fall out of the air on the side of the mountains that the wind's blowing. And then as it goes over the mountain, it's going to be a lot drier now that there's no water there anymore. So oftentimes you get what's called a rain shadow, which is where it's very dry. There's not very much vegetation. Okay, so you have a picture here. Again, evaporation from the ocean. These prevailing winds pull this water onto the land as it goes up the mountain. It condenses and cools. It falls down as rainfall. So you get lots of trees and lush vegetation here because it gets water all the time. And on the other side, we have a rain shadow where it's much drier. There's much less vegetation, and it's typically going to look very, very different from the other side of the mountain. Okay, very common. All right, the last thing we have here are seasonal winds. So seasonal winds are basically winds or weather patterns that come down or that happen seasonally. They're similar to land and sea breezes, but they occur over a very, very wide area, much larger than the prevailing winds. Okay, and a lot of times they will change direction with the season. So we call these monsoons. So prevailing winds are going to be in the same direction all the time. Seasonal winds will change directions. Okay, so monsoons, in a summer monsoon, wind blows from the ocean onto the land. Produces a lot of rainfall because it brings a lot of humidity and water vapor with. It falls on the land, it rains. They get flooded, okay, floods. Like not just rain like it's raining normal, like lots and lots and lots of rain, and they get flooded. It's crazy. But then in the wintertime, the winds change direction, and now they're going to be blowing from the land to the ocean, and we get the opposite effect, where they're going to pull a lot of the water from the land out towards the sea, in which case, instead of getting a lot of rain, they get very little rain, and oftentimes this results in droughts and in dry seasons and dry spells where crops don't grow and things like that. So places like this are going to be like around India and the Philippines and places near the ocean where this happens. It can be very devastating for farmers, especially on their crops when they get flooded or they get no rain, and it happens like that. So they need to plan their growing seasons accordingly. Now here in the United States, we don't have monsoons. We get hurricanes, which are similar, right? Obviously here in Minnesota, we don't get affected by them, but we know that on the East Coast of the United States, New York, Florida, they get hit by hurricanes like all the time, and it can have a big impact on their climate there. So. All right, so what causes the seasons? So as most of you probably know, the Earth is tilted, okay, about 23.5 degrees, which means it's not straight up and down. This means that the sun, as it hits the surface of the Earth, is not hitting it straight on, but instead hits it at an angle based on where you live on planet Earth, right? So as the Earth revolves around the sun, right, as it goes around the sun like this, the tilt of the Earth doesn't change. So the Earth is always tilted like this, right? Whether the sun is here or whether it's here. Doesn't matter. And so in the northern end, when the sun is pointing away from the sun, or when the northern end of the planet is pointing away from the sun, so here's the sun, here's planet Earth, the northern part of the planet is going to get hit by the sun's rays more at an angle. A lot of the sun's rays is going to deflect off into space, and not as much of the heat is going to get absorbed into the air and onto the land. Versus in the other time of the year, when the northern part of the planet is pointing more towards the sun, again, sun's here, Earth is here, sun's rays are going to hit more directly, in which case a lot of the heat is going to get absorbed into the air and onto land. And so what this means is, in the northern hemisphere, when we are pointing towards the sun, this is going to be our summertime, when most of the sun's rays and energy are going to get absorbed by the air and the land. And this is, of course, going to heat up our temperatures here and make it summer. Likewise, if we're pointing towards the sun, again, here's the sun, here's planet Earth, we're pointing towards the sun, the bottom part of the planet, the southern hemisphere, is pointing away. And so this is then their winter time, okay? Likewise, when we're over here and the sun's here and we're pointing away from the sun and we're getting hit more at an angle and we're not getting as much heat, so it's our winter, the southern hemisphere is getting hit more at an angle, and that at that point is their summertime, right? So these are the reasons why we have seasons, and of course this has a big impact on climate and temperature. An image here again is shown just to kind of visualize this a bit better. Here on the left, this is our summertime. Here, the northern hemisphere, when we're getting hit more directly head on. Southern hemisphere, this would be their winter since they're getting hit more at an angle. And on this picture on the right, this would be our winter time as we're getting hit more at an angle since we're pointed away. And the bottom is getting hit more directly, so this would be their summertime, right? And then again, here on both the top and the bottom, this would be the fall and the spring, where it's kind of a medium ground because we're not pointing towards the sun or away, we're just kind of sideways, so it doesn't really have as much of an impact on us. And yeah, so all right, guys, so that is it for this section of notes. Again, if you want to see me go over the questions, I have a video of me doing that. You can go watch that one, but that is all for this section. So I will see you in chapter 18.2. Bye.